The last step now is to create what we call the results. Okay, so we need to create our percentage of error. In some other labs you'll be doing a percentage of difference. In this one we're going to do a percentage of error. And to do that we need to look at our two values, the experimental value for the acceleration of gravity and the theoretical value for the acceleration of gravity. And we need to pull these into that relationship. I think some folks are having a problem with that absolute value because I keep seeing negative signs coming up. The negative sign means you cannot have a negative, the absolute value means you cannot have a negative value. So let's take a look at how we can do this and build this in Excel and maybe not see those errors anymore. So what we're going to do is build another array here for our percentage of error. So I'm going to go ahead and insert it into the graph here. And so for the theoretical value, I've just entered that value, 9.8. We know that the units are meters per second squared. For the values that you calculated, your experimental value, that's that value of 9.2. That's up here in the cell D30. Okay, you could copy this down if you wanted to and just tell it to find the value, but it's easiest just to type that small of a number in. So the last step is we do this comparison between the two by taking the absolute value of the difference of those two numbers, which gives us always a positive value, and we divide it by the theoretical value. So how do I set this up in Excel so that it calculates it for me? Well, if you look up into the top here, into the formula bar, you can see that we have type an equal sign, type ABS for absolute value. It doesn't put those straight up and down lines, but it creates a parenthetical expression here of the theoretical value, in this case the value in C36, subtract from it the value in D36 and divide it by C36. So when you do that, you end up with a value of 6.12. The last step that you need to do is come to the top of the menu bar here, and where it says percentage, you don't have to multiply times 100. You could do that. I could have done that right here if I wanted to, but why not use the power of the software and just hit the percentage key? When you hit the percentage key, it converts it to a percent of error. This is the value that you need to be reporting in your abstract, and this is the value that you need to be reporting in your discussion. That is the results. You need to make a result statement. Don't put any of these intermediate values in your abstract or your discussion. Don't describe any of the procedures that we did in your abstract or discussion. In the theory section, you can put those relationships that we did here to calculate the from the slope to the gravity. Those are certainly welcome, but none of those other procedures belong in the discussion or the abstract. If you do that, I'm going to ding you for it. The other thing is, don't use the cliches in this lab or we did this experiment, blah blah blah. It's cliche. It's dead wood. Start, with something that describes overall the activity that you did for this lab. Something like calculating the experimental value of gravity can be done by using graphical analysis. That is a perfectly acceptable, good lead-in topic sentence. But starting off with in this lab or we did this experiment, no good. That makes for a very poor report. So we've gone through all of the steps from the data to the calculations to coming up with to the graphing to coming up with the calculations of gravity, and then finally the last step, the percentage of error. I hope that this lab video helps you in the future, because you will see other applications of Excel in physics lab. Thank you.